In this video, we will introduce the Pick and Place robot. The Pick and Place robot picks a part up at one station, rotates to another station, and places it there. It can pick up and deliver one or more parts. Let's build a simple model. We insert a source and a conveyor. Now we select the source, the conveyor, and the connector, and copy them by clicking Ctrl and C. Then we paste them by clicking Ctrl and V. Then we insert a Pick and Place robot, a station, another conveyor, and a drain. Now we connect the two conveyors and the station with the robot. We then reduce the processing time of the station so that the robot has always free place to put the part. If we start the simulation now, we will see that the robot picks the parts at the conveyors and places them at the station. Now we will have a look at the dialog of the Pick and Place robot. To do so, we double-click on it. We see that we have an angles and times table. The angles table defines the objects from which the parts are picked or to which the parts are delivered, and for a 2D model, also the angles for the different objects. The angles do not matter in a 3D model because the robot automatically determines the correct joint positions from the layout. In 2D models, the angles determine the rotation of the icon. The timetable shows us the times the Pick and Place robot takes to rotate from one object to another. All the objects shown here are the ones from the angles table. We can see, for instance, the times the robot has to rotate to get from the first conveyor to the station, and vice versa. We also see how long it will take to rotate from the default position to the conveyors or the station. Let's assume now a production line where the robot lifts car bodies. When the car body is loaded, the robot will not need the same time as if it were rotating empty. We can illustrate this behavior by editing the times table. All values below the diagonal give us the times needed by the robot in loaded state. This cell shows us the time the robot needs from the first conveyor to the station in loaded state. We will enter here 30 seconds. Let's start the simulation now. As you can see, the robot takes now longer to rotate with the MU loaded. You also see that the path the robot takes to the station is the shortest path possible. However, in this way, the robot collides with the station. If you want that the robot should follow a specific route while rotating, you can do this in the 3D properties of the robot. Therefore, we open the context menu of the robot by right-clicking on it. Then we select Edit 3D Properties. We could also select the robot and click on Ctrl and 3 as shown. Now we switch to the Robot Arm Animation tab. We click on Add. In this pop-up, we need to select for which animation path we want to specify the route. We select from conveyor to station. Then we click on Show. By specifying an animation path, we tell the robot to first rotate to the cone after picking the part, and then to the station. The same applies for the way back from the station to the conveyor. Now we can select the cone and adjust the position by using the arrow keys. By holding the Shift key, the position will move by 1 meter steps. By holding the Control key, the position will move up and down. or we can simply drag and drop the cone with the mouse. If you have exact coordinates, you can also double-click the cone and enter a specific coordinate. After finalizing the position, we start the simulation again. As you can see, the robot will now, instead of taking the shortest path to the station, first rotate to the cone and afterwards to the station. However, the robot still does not take a collision-free path. Therefore, we need to insert more than one cone. To do so, we select the animation path in the dialog and click on Extend. We can now insert as many cones as we want by left-clicking the mouse. We can exit this operation by right-clicking.
We now use again the arrow keys to adjust the position.
After finalizing the positions of the cones, we start the simulation. As you can see, the robot will now take a collision-free path. Now we create a second example to showcase how you can use the pick and place robot without connectors. First, we insert a source and a conveyor. Then we insert a second conveyor and a drain. In the middle of them, we insert a pick and place robot. As you can see, the robot is now not on the end of the first conveyor nor the beginning of the second one. So we can't use connectors. In this case, we can drag and drop the robot to the desired place where it should pick up the part from the first conveyor. Now a dialog will pop up that asks us to select an operation. We can choose from 4 different operations. In our case, we choose to pick a part. As you can see, Plant Simulation will create a sensor which is visualized by a red line. When the front of the arriving part has reached the sensor, the pick and place robot is triggered. Then we do the same process with the second conveyor and select Place Part. Examples for the other 2 operations will be shown in video 23. We start the simulation now. If we want, we can change the position of the sensor. There are 2 ways to do this. The first one is by zooming in and selecting the sensor. Now we can move the sensor with the arrow keys. We can also hold the Shift key to move the sensor by 1 meter steps. Now we double-click the sensor. Here we can see at which position the sensor is placed and the trigger point. For the trigger point, we can select front, rear, or booking point. To get more detailed information, we can use the question mark in the title bar. If we click on it and then on booking point, it will provide us further help and an explanation. The second way to change the position of the sensor is by opening the dialog of the conveyor and clicking on the tab controls. Here we can see the sensor box. If we click on it, a list with all sensors on the conveyor will open. If we now double-click the sensor, we can again edit the trigger point and the position of the sensor. Now we want to demonstrate the exit strategies of the robot. Therefore, we switch back to the first model. We first reset the times table, then we copy and paste the station, the conveyor and the drain. Instead of selecting the objects separately, we can also just drag the mouse over the objects. In this way, the connectors will also be selected, and you do not have to select them separately. Now we will have a look into the exit strategies of the robot. To do so, we open the dialog of the robot and click on the Exit tab. Here you can see that target selection is set to Exit Strategy or Target Control. Now we change the exit strategy to percentage and click on Apply. Then on Open List. In this case, we do a 70-30 split and start the simulation. The robot will now distribute the parts accordingly. Now we will have a closer look at the axes of the robot. Therefore, we insert another robot into the model frame. Then we right-click the robot and select Show Graphic Structure. In this dialog, we see the different axes of the robot. The Pick and Place robot has 4 axes. You can see the number of axes by counting how often you can expand an entry until no additional nested entry exists. We can also exchange the graphic of the Pick and Place robot with other ones. Therefore, we select the robot and switch to the Edit ribbon. Here we can click on Exchange Graphics. We also can open the context menu of the robot and select Exchange Graphics. Now the folder S3D Graphics should open. If this is not the case, we select the according plant simulation version that is running and extend it. Here the S3D folder should be found. In the folder are a variety of existing graphics we can use. We select the Comau Pick and Place robot and click on Open. As you can see, the graphic of the robot did change. If we now again look at the structure of the robot, we will see that the new robot has 6 axes. This Comau robot is a typical example for a 6-axis robot. The automatic calculation of the joint settings for picking or placing a part is only supported for specific types of axis configurations. To get information about supported configurations, you can have a look at the online documentation. Therefore, we open the dialog of the robot and click on the Help tab. Then we click on Help on Object. Or we can simply press Shift and F1 as shown. You can also just select the robot and press F1. We then scroll down and click on Configuring the Pick and Place robot in 3D. Plant simulation can only calculate the correct joint position if the robot has one of these configurations supported here. As an example, the 6-axis robot is shown now. If you scroll further down, you will see further examples. This concludes our video about the Pick and Place robot.